All right, so we've opened Microsoft Excel here, and we're going to use it as a tool to find an equation that fits a set of data. So the first thing we're going to have to do is enter the data. And unfortunately, yes, I'm making you do this by hand. So you have to go through and, for the time and for the height, enter each of those pieces of data. When the time is 0 seconds, the height is 2 meters, etc., etc., etc. And so you've entered all the data up to 2.1 seconds. And that'll look like this. I guess we went up to 2.2 seconds. Once we have this, we are going to use this data to create a graph. So I'm going to select all of it. And to do that, I'm going to click in the middle of the box and drag to select everything. What I really want to make sure that I don't do is click anywhere near the sides of the box when I go to drag, because that's going to do something other than select the data. So click in the middle and drag, and so you have all the data. Then we are going to insert a graph. So we're going to hit the insert button up here in the top ribbon. And we're going to have a bunch of options, including inserting a number of charts. We're always going to use a scatter plot when we're trying to fit data. So we're going to pick the scatter plot here, and just the basic scatter plot is going to be fine. So we'll pick that. Now, as we take a look at this data, we can see that it has the general form of a parabola. So our guess is that we're going to have to use a quadratic equation to fit this data. In the first part of the unit, I'm always going to tell you what sort of fit we want, but later on in the unit, you're going to be expected to recognize that this is a parabola and that therefore you want to use a quadratic. So let's get this title out of the way for now because we don't need it, and just look at the data. You can see that we have height graphed on the y-axis and time graphed on the x-axis. So as time goes by, the ball goes up in the air and then it comes down the other side. Okay, so now we want to find the equation of the graph. So we're going to come up to the little plus sign in the top right here, and we're going to add a trend line. Now, you can see that if I just check the box, it puts a straight line through my graph, which is totally meaningless. This straight line doesn't tell me anything at all. And that's because we don't actually want to use a linear regression here. We want to fit this as quadratic data. So we're going to have to go into the options for my trend line and pick a different option besides linear. Now, unfortunately, it doesn't have a better option for me here, so I'm going to have to go into more options. And then I have all these possible things to choose from. What I want in this case is a polynomial of order 2 as my graph. And you can see that now it's got that dotted line that's joining my actual points here. I'm going to do two things. I'm going to tell it to display the equation of this parabola on the chart, and I'm also going to hit this display r squared value on the chart. Right now, you'll see that this r squared is equal to 1, which is just telling me that I have a perfect fit, that my dotted line here is absolutely perfectly fitted to all the points that I gave it. And for the first little while, we will only look at situations where r squared is equal to 1, so we know that we have a perfect fit. And then later, we'll look at some imperfect fits as well. But I have my equation here. My equation is given y equals negative 4.9x squared plus 10x plus 2. So that's what I would write on the page as my fully fitted equation. That's what I'm looking for, and that's what you have to do for the rest of the questions on this page as well. So thanks for watching.